So in this video today, we're going to talk about arcs and chords and circles and central angles. So we're going to do IOA 7A, which is identify and apply angle relationships formed by chords, tangent, secants, and radii. Okay, so that's actually the lesson today. So our objective is I can differentiate between minor and major arcs, and I can find and determine their degrees, and I understand the relationship between central angles and arcs. Okay. So central angles and angles whose vertex is the center. So notice right here, this is angle ABC's vertex is right there at the center of the circle. That's the central angle. Now an arc is an unbroken part of the circle that consists between two endpoints called, or 2 points called the endpoints, and all the points. So basically this is arc AC right here, okay? And hopefully all of y'all know that a circle consists of 360 degrees. So we're going to talk about each of these. A minor arc is an arc whose points are on the interior of a central angle. So basically a minor arc here, in the measure of a minor arc is equal to the measure of its central angle. So that means if this angle is, let's just say 60, then this arc right here is 60, okay? Now a major arc is a point, is an arc whose points are on the exterior of a central angle. So that's this out here. So it's going to consist of 3 points. Normally we name a minor arc right here with 2, AC. This is major arc right here, ADC, right? So on this one, because if I said this was 60, the whole circle is 360, right? So to find this one, we would do 360 minus the 60, okay? So that's what we would do. So let's just again say this was 60. So that means that arc right there is 60. Okay, if we said this is 60, then if we're trying to find arc ADC, we would do 360 minus the 60. So arc ADC would be 300 degrees. Okay. Now the other part is if the endpoints of an arc lie on the diameter goes through the center of the circle, right? Then this is a semicircle. That means it's half the circle, and hopefully everybody knows that 360 divided by 2 is 180 degrees, okay? So that is a semicircle. And we're going to use all of these in a minute, okay? So the next thing it says here is adjacent arcs are arcs of the same circle that intersect at exactly 1 point. So arc RS here is equal to ST. Now, the next thing that leads to is that if we have the arc addition. So let's just say that this was that 60 degrees, right? And this was, let's just say 20. So to find if arc AB is 60 and arc BC is 20, so arc AB is 60, arc BC is 20, then what would arc AC be? We would add those two. So we would add the 60 plus the 20, and that means arc AC would be 80 degrees. All right, so remember again that central angles or their vertex is at the center here. So if we start talking about these arcs here, so for this first one example, this is 97.4 because that central angle is 97.4. This one right here is 52 because that central angle is 52, okay? Now I notice if I'm looking at this that this angle is congruent to this angle because we have a diameter there, we have a diameter there, right? So those are vertical angles, aren't they? So we can say that this is 97.4 degrees, which means this out here is 97.4 degrees. Now again, this is true because the angles are at the vertex. The vertex of the angles are at the center of the circle. Now, let's figure out, it's asking us for BD. So to find BD, we need DC, don't we? Okay, so notice here that we've got half the circle. I like to draw these lines big, right? So that half the circle is 180, isn't it? So we can do 180 minus our 97.4, also minus our 52. That's going to give us that DC, right? So DC is, let me put my glasses on, I can't see, 30.6 degrees, right? So this right here, so we're looking for DC right now, y'all. DC is equal to 30.6 degrees. This right here is 30.6 degrees. Okay, now let's talk about what it's actually asking us to find. It's actually, this problem's asking us to find arc BD, right? From here all the way around to there, okay? So what does that mean we have to do? We have to add these two pieces together, don't we? So 97.4 plus our 30.6 is going to be 128 degrees. Okay? Now the next one's asking us for EBC. Okay, so let me see if I can find a different color here so we can see it. Start with E, and then we're going around to B, and all the way to C right here. See that? So that's all of that purple, EBC. Now we know it's not the other way because it would be out of order if we had the C in there, right? If we went the right, it would be ECB. That's how we know the direction we went was correct, okay? So now this time I'm going to, do you all see that this right here is not included in our circle? That's not included in the purple, right? So what I'm going to do is I'm going to do 360 minus our 52 minus our 30.6, okay? So when I do that, that's going to be 277.4 degrees, okay? So let's see if we can work through this drawing of this next one before we go any further. So before I even start doing anything, I'm going to look at the drawing. Again, do you guys notice that these are two diameters? So these angles are going to be congruent, aren't they? Because they're vertical angles. So this angle right here is also 25 degrees, which means that arc is 25, right? Okay. Then I notice that this one right here is everything but that, right? So that's half the circle. So to find this part right here, couldn't we do 180 minus the 25? We can, and that means this part right here is going to be 155 degrees. Now remember, that also equals that arc, right? Okay, now up here, y'all see this up here? Again, we got half our circle, right? And we have 25 up there, and we have 40 up there. So once again, I'm going to do 180 minus, that's 65, right? 40 plus 25. So that's going to be equal to 115 degrees. So that's this right here. Now I like doing this first, then I can answer the questions that I'm being asked, okay? So the next one is, what's the measure of JKL? Measure of J, again, going to K, then we're going up here to L, right? So what two pieces are we about to add together? We're going to add the 25 plus the 115, and that equals 140 degrees, okay? I'm going to find a different color here, okay? So now LJN is L, starting with L, going around to J, and then all the way around to M. Y'all see that right there? So here again, everything's included except for 40, right? So this time we're going to do 360. Wait a minute. LJN. Sorry, my bad. I messed up, y'all. It's LJN. So it's right here, right? So it's LJN. So we're going to subtract the 40 and the 25, right? So that's going to give us 295 degrees for that one, okay? Pause the video here and see if you can do the next couple. Come back to me when you're done. All right, so I know I'm going to go in here and start doing some things. I know this is 90, right? Okay. Then I also know that these two are congruent because, again, see that diameter and that diameter, vertical angles, right? So this is going to be 38 degrees. To find this one right here, how would we find it, guys? Don't we have half the circle again up here? See half the circle right here? So we could do 180 minus the 90 minus the 38. And when we do that, we get that this is going to be 52, right? So that right there is 52 degrees. Now, how would we find this one down here? Again, we got half the circle, right? So down there, we're going to do 180 minus our 38, right? And that one's going to be 142. Again, I like doing what's in this first, okay? Then we can figure out what the arcs are, okay? So our arc DF, we're going from D to F. Now, I'm not going to go the long way around to F. I'm going to go the shortest way because it's two letters, okay? So to find the measure of arc DF, we're just going to add, that's going to be equal to 52 plus 38, right? 52 plus 38. Where's Mark DF? 52, I'm doing this with my calculator, y'all. 52 plus 38 equals 90 degrees, right? Ooh, I just noticed something is because of that. Y'all see this right here? See that right there? That was half the circle too. And if we had already used 90 right there, then those two have to add up to be 90, right? Sweet. Like it. Okay. So then we're talking about HGF. Okay, so I'm going to do this one in green, HGF. H to G to all the way to F right there, HGF, okay? Notice, what is that? Isn't that half the circle, y'all? So the measure of arc HGF is going to be 180 because half a circle is 180. Agreed? Good job. Okay. The next one. If you haven't done it, pause the video here. Come back to me when you're done. So here again, this is 90, right? Trying to see if we have some diameters here. We have a diameter right there, don't we, guys? So that means I can find this piece right here by doing 180 minus the 90. That would be 90 minus the 74. So that little sliver right there is going to be 16 degrees, right? So I'm just going to write it out here because I don't think I can write it in there, y'all. This right here is 16 degrees, okay? Then I notice that we have two congruent angles right here. Y'all see these two are congruent? So again, we got half our circle right here, so we can do 180 minus the 82, and that's going to be, where did I do that? 180 minus 82, that's going to give me 98, right? And then we're going to divide that by 2 because those two angles are the same, right? So we're going to divide that by 2, so that's going to be 49 and 49, okay? And again, I like to label what's in there. Remember, whatever's on the outside, this 82 also goes right there, doesn't it? Because the arc equals the angle because it's the central angle. So then it's asking us for CB. So again, I'm going to use my colors here. CB's right here, right? So CB's right there. So the measure of CB is 49. We already found it, didn't we? So that's 49 degrees. Easy. Okay, then measure of ECG. So let's use our lovely little purple again. E, G, all the way around to C, okay? So see that right there? That's all of this stuff that's in the purple space. So we could add all that together, right? But it looks to me like it includes everything but this stuff up here. Y'all see this here and this here? It includes everything but that, right? So couldn't we just subtract those two from 360? So we could do 360 minus 90 minus the 49. So when we're looking for the measure of ECG, what did I get? The measure of ECG was 221 degrees. Okay. So this next one says, find arc CB and then find the measure of ADB. Okay, so find the measure of both. So what I noticed again is that these two equal each other, right? So that means this 2x minus 19 goes there as well. Now listen, what we're going to do is we're going to add all these together because what is a whole circle? 360, right? So we're going to add the 65 plus the 3x plus 4 plus 2x minus 19 plus 2x minus 19, and all of that should be equal to 360, right? Right. So we're going to combine some like terms. So I got a 65 and a 4, that's 69 minus 19 would be 50, right? 50 minus another 19 would be, what did I get here? 31. So this is 31, and then here's our like terms. 3x, 2x, that's 5x, plus another 2x, that's 7x, right? Plus 7x, and that equals our 360, right? So now we're going to subtract the 31 from both sides, right? So 7x is going to be equal to 329. Then we're going to divide both things by 7 here. So x is going to be equal to 47. Now we're not done because we got to plug it back in, right? So we could just plug it in everywhere. We can figure out where we need it. So let's just figure out where CB is, right? So CB is the shortest distance, because there's only 2 letters, between C and B, right? So then we're going to do this 3 times our 47 plus 4. 3 times our 47 plus 4. So 3 times 47 plus 4. Trying to figure out where I put CB on my paper, y'all. I'll just do it on my calculator. 3 times 47 plus 4 equals 145. So this one's equal to 145 up there, right? Then ADB. Okay, let's talk about that one. We'll do that one in green, okay? So A, and then around to D, and then around to B. Okay, so we got to go the order of the letters, right? So this time, it's going to just be these 2, right? So 2x plus 2x is 4x. Minus 39 and minus 39, minus 19 and minus 19 is minus 38. So can't we just plug in our x there? So that's going to be 4 times 47 minus 38. 4 times 47 minus 38 is 150 degrees. So this one up here is 150 degrees, okay? So the next one, again, what are we going to do to all 3 of these? We're going to add them together, right? So we're going to add 92 plus our 4x plus 15, plus our 6x plus 3, and all of those are going to add up to be 360, right? Because the whole circle's 360. So once again, we're just combining some like terms here. So if we do 92 plus our 15 plus our 3, I got that that's 110. Yep, 110. And then we're going to combine our 3x and our 4x and our 6x. So that's going to be, plus 10x, right? And that equals 360. Recall again that we got to subtract our 110, subtract our 110. So 10x equals 250. So x equals 25. So we're going to solve for that x first. Then it's asking us for BD. So here's BD from there to there. We're not going to go around the long distance. We're going to go the short distance because it's 2 letters. So to find BD, right, aren't we going to just do 6 times our 25? That's 150 plus 3. So that's 153 degrees, right? That's our BD. We good? Okay. Then let's look at DAB. You know what? Let's just do it in blue. D around to A, around to B. Look at that. I like that one because all we have to do is what? All we have to do is subtract what we just found, right? So we just found 153, right? So 360 minus, because look, this is what they're asking us to find, right? It was everything but what we just found, right? So 360 minus 153, that's going to be equal to 207 degrees. So that's the measure of DAB, right? Okay, let's see if you guys can do this U-do down here. This one's easier. We're not having to solve for x. You just find them, okay? So go ahead and do this and come back to me when you're done. So this 105 can go in here, right? Okay, so how again are we going to find, and the 67 can go in here as well, right? Or on the outside, doesn't matter because these angles are equal because they're central angles, right? So how are we going to find that missing piece? Aren't we going to add all these pieces together? Let's do it. 40 plus 82 plus 105 plus 67. 40 plus 82 plus 105. I'm doing it on my calculator. Plus 67. That equals 294. 294, right? So then we're going to take 360 and subtract that 294 from it. And when we do that, we get 66. So this piece right here is 66 degrees, okay? So then we're going to find EF. Well, that was EF, wasn't it? This is EF right there, right? So this is 66 degrees. Kind of interesting they gave us that one first, right? Now it's asking us for angle FAC. So angle FAC, okay? So let's do that one in red. FAC, right? So don't we just have to add up these 2 parts right here? So that's going to be 107, right? Okay. Let's find another color and see what we can find. Okay, the next one is DEF. So we're going from D, around to E, and then over to F, right? So we're going to find these two pieces, right? So we're going to add 66 plus 82. That's going to be 150, isn't it? Let's double check. 66 plus 82. Ooh, no, I can't add today. 148. Tired, y'all. Okay. Then let's look at DAB. Find one more color here. I'm going to use purple. Okay. Angle DAB. Angle DAB. Again, that's the angle that consists of those, right? So on this one, we're going to do 67 plus 105. 67 plus 105 is 172. So there we go. All right. So this next part says within a circle or congruent circles, congruent arcs are two arcs that have the same measure. Okay, so what does that mean? That means that if it shows us these two angles are congruent, then these two arcs are congruent. It also, so that's why it says in the figure, arc ST is congruent to arc UV. Why? Because the angles are congruent. Those central angles are congruent, the arcs are congruent. We know that. So here's another piece though. Congruent central angles have congruent chords. So that means this, if these angles are congruent, then the chord right there, ED, and the chord CB are also congruent. Okay, here it says this congruent chords have congruent arcs. So again, if we knew the ED was congruent to CB, then we knew that the arc ED is congruent to arc CB. And then lastly, the congruent arcs have congruent central angles. So if we know this already. If these two arcs are congruent, then that angle ECD and CAB or BAC, however you want to say it, are congruent. These arcs are congruent. Those two angles are congruent. Okay. So here it shows us that these two chords are congruent, right? It says TV is congruent with WS. So that means that this arc right here is congruent with that arc. That means we can set them equal to each other. So 9n minus 11 equals 7n plus 11. Okay. So what we're going to do is subtract 7n minus 7n. My n's over there are now gone, right? So I got 2n over here. I'm going to add 11 to both sides. So my 11's are gone from there. And we got 22, right? So divide both sides by 2 here. So n is equal to 11. Now, it didn't ask us for n, did it? It asked us for WS. So it asked us for this arc down here, right? Okay. So WS, arc WS, is going to be equal to 7 times 11. That's 77 plus 11. That's going to be 88. Now listen, you can check this by putting this value into the other one as well. So if we use the other arc, which is 9 times 11, that's 99 minus 11. That's 88 as well, right? So there's our check, okay? No reason to get something wrong that you could get right. All right, here's our next one. That we do. So here again, we got that a chord is congruent with a chord. That means that this arc is congruent with that arc, right, y'all? Okay, can't draw well today, but we could say arc SR is congruent with arc TS, right? See it? Okay. So we can then set them equal to each other, right? So 115 equals 7x plus 24. How do we get rid of that 24? You got it. Subtract it. Okay, when we do that, trying to find my lovely little key here. I got 91 here is equal to 7x. Divide both sides by 7, right? So x here equals 13. And this time it told us to solve for x, right? We got the arcs. They're both 115, okay? So again, the you do 3. Go ahead and do it. Come back to me when you're done. So once again, these arcs are congruent because the chords are congruent, okay? So we're going to do 25y equals 30y minus 20. So I'm going to subtract the 30y from both sides. So what's that going to give me over here? That's now gone, right? So we got minus 5y equals minus 20. Divide both sides by a negative 5. What's a negative divided by a negative? That's going to be a positive, right? So y is equal to 4 here. And then it's asking for this arc right here, right? So CD is equal to 25 times 4. You got 4 quarters. How much money y'all got? 100, right? There we go. And then we're going to check it with the other one. So EF is going to be equal to 30 times 4. Isn't that 120 minus 20, which is also 100 degrees. So there's our check. All right, here's our last one. Applying congruent angles and arcs and chords. So this one says that circle C is congruent to circle J, and that the measure of angle GCD is congruent to the measure of NJM. So if these angles are congruent, what can you tell me about these two chords? They're also congruent, right? So this chord DG is congruent with this chord NM, right? DG equals NM. So we're just going to set them equal to each other, right? 14t minus 26 is equal to 5t plus 1. So let's go ahead and subtract the 5t from both sides. Okay, when we do that, that's now gone, and we got 9t over here, right? Then we're going to add the 26 to both sides. So that's going to be equal to 27 now, right? That's now gone. How many times does 9 go into 27? So t is equal to 3. Now, it's not asking me for t, right? What is it asking me for? nm, right? So that means we got to put it back in nm. So nm is equal to 5 times 3. That's 15 plus 1. So this is equal to 16. So here's my question. What should dg be equal to? The same, right? dg is equal to 14 times 3. That's 42. Minus 26, which guess what? That's also 16. So we checked. Okay? All right, do the you do and come back to me when you're done. Ooh, we got to turn bisect here. So that means this is congruent to this, right? Okay? So then again, that means 6x is equal to 20 minus 4x, right? So let's add the 4x to both sides. Now it's gone from there, so we got 10x equals 20. Divide by 10. So x equals 2, right? So when we're looking for RT, these chords are equal, right? RT is equal to TS, okay? So RT is 6 times 2. That's equal to 12. That's RT, right? And then this TS is going to be equal to 20 minus 4 times 2, so 20 minus 8 is, guess what, 12 again. There's your check.